If we're going to be using piecewise functions, we're also going to need to know how to take the inverse Laplace transform with step functions. The indicator that we have a step function involved in the time domain, or in the t's, is that there's the negative exponential with an s in it in the transformed version. Fortunately, the table entry here is all we really need to handle this case. Let's do a few examples with that in mind. What we have here is an exponential times the transform of something we know. So the key thing here, this f of s here, is a function in the table. And let's make that explicit in this case here. We're asked for the inverse function of e to the negative 2s times 1 over s squared. This is the Laplace of t. So, or if you want, this is our f of s equals 1 over s squared, which is in the table. What does that mean when we apply this more general table rule? Well, what we get is for sure a step function, u sub a. So we get a u2 of t. So that's that step that's on at t equal 2. What do we do for the rest of it, though? Well, we would have had the function t, but this transform is saying, no, we don't get t. We get the same thing we would have got, except with all the t's replaced by, when we go in this direction, by t minus a. So in this case here, the function that we're inverting is t, so we end up with a t minus a. Oh wait, what's a? It's 2 in this case. We had e to the negative 2s, so we end up with t minus 2. So we see again that when we have step functions involved, or the transform versions, like e to the negative as here, there are two consequences for the inverse. We get a step function at that point that turns on at that point, and we also shift any t's by t minus a, or replace them with t minus a's. Let's try that again with this function here. Again, we can write it out as e to the negative 3s times 1 over s minus 4. And this would be the Laplace transform of, in our table, s minus a is a regular time exponential, so e to the 4t. And what we need to combine here is this, the presence of this exponential here says we get a step function on at time 3 times the transform we would have gotten, e to the 4t, except every t is replaced by t minus 3. Again, that same 3 in both locations, that a in both locations. Again, with practice, this becomes more familiar. Do take advantage of the practice problems for this week as early as possible.